nice to see you. Thanks for driving. We can go right in here and sit down.
Okay. Okay.
So what I wanted to show you is there's a really nice lady across it. Look who's here! Look who's here! It's Miss Bird. Isn't this great?
I
Wow.
missed you guys.
Okay. She doesn't know it, but I'm going to ask her to help me with a math video later. Just kidding. All right. Now, I'm going to donate a lot of these to kids. Her church does a thing where they collect and they distribute these to kids that don't have toys. And I just wanted you to see it. And then I wanted to talk to you about a few other things. And I thought it would be a nice place just to sit here. We got the camera going, so we can say hi to all the kids. All the Access kids are over there. How you doing?
Hey,
Okay.
guys.
Oh, I got to do something on the other side of the house. I'll be right back.
Okay, I'll be here.
Oh, here we go. Oh. 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 What happened? Well, this is kind of embarrassing. Anyway, I gotta, that thing's leaking water. I'm gonna have to take a look.
Oh, okay.
All right?
Okay.
Okay. So I'll just put it in here. You can put it in here. Okay. I don't see it.
Oh, okay.
I don't know. What the heck? Whoa! This bird! Whoa!
Are you okay?
Oh, I got some in my eye. Oh, no. Greetings, Pepin Falcons, and welcome to another edition of Math is More Than Fun at Pepin. I'm your host, Mr. Newber, and today we are going to I'm going to make a presentation. Wait a second. I gotta keep turning all the way here. That was a rough session with Miss Bird out there. I got hit right in the eye. Okay, I'm probably what? Oh, my hair. Something's wrong with my hair. Okay, all right. Okay, we're all set. This is the demonstration that I promised you that I was going to do in our unit on fractions, decimals, and percentages. Okay, so I told those of you that I had today on Wednesday. I told you that I had my course up here, and this is what I want to do. All right, the first thing I want to do is show you a quick review of long division. This is going to be real quick. I know that in long division in the past you've had maybe 2 or 3 numbers dividing into 4 or 5 or 6. We're doing this for fractions. We don't need to do all that, all right? So I want to teach you something. Mrs. D loves to do this. She teaches this way. She says this is a house. I'm going to use that at more like an arcade, okay? And there is a number out here, and we're going to divide that number into the number that's in the house. So I tried to think of a way that I could show this to my grandsons and they would understand. So I'm going to tell them there's 9 of those real fun games in the arcade that you sit in. You know, the one, the mine, where the car goes through the mine, or it's a jet plane flying through the... Okay, there's 9 of those, and there's 3 people outside. Is there room for 3 people in 9 seats? Yes. So that means this can divide into here, and this is what you need to do, is if you know your multiplication tables, or if you can count by 3s, which I'm going to mention later, you would know that 3 times 3 equals 9, so there's 3 9s in here, and that would be your answer. Real simple, okay? How about another one here? How about 3 and 12? All right, so we're going to divide 3 into 12. Once again, we have 12 games now in this other arcade, okay? and there's 3 people who wants to go in, me and 2 of you, all right? Is there plenty of room? Yeah, there's plenty of room, which means somewhere on your multiplication chart, or if you have a calculator that you know how to use, there is a number times 3 that equals 12, and that number is 4. So that one's pretty easy too. How about another one? How about this one? We have a couple of steps in this one. Okay, let's say that we make a trip to Jacksonville where they have a lot of these arcades, all right? And there are 63 of these seated games in the arcade, and there's still just 3 of us, all right? So we're not going to take 3 into a 2-digit number or a 1-digit number. 3 actually will go into the 6. And if you know your multiplication, again, 3 goes into 6 2 times, because 2 times 3 equals 6. And so we multiply that and put this here, and now that 3, or that 6 is gone. Now we bring the 3 down, and of course 3 goes into 3 once. So the answer is there's 21 3s inside 63. And then the last one that I used is one we all are aware of, and somebody might say, I don't need arcades for this one, Mr. Newber. That's how many nickels are in a quarter, all right? That's 5 into 25. If you have 5 nickels in your hand, 5 times 5 is 25. So the answer to that one is going to be 5. So let's make this a little more interesting, especially when we have plenty of seats for everybody to go in who's out here waiting. How about this one? And this is what you're going to run into when you work with proper fractions, because with a proper fraction, you're dividing the denominator into the numerator. And everybody knows a proper fraction, the denominator is a larger number than the numerator. So the one I have here is 4 into 2. Okay, what do we got here? Well, what we have here is we have a very small arcade, all right? Maybe it's like in the back corner of a Winn-Dixie or something. There's only 2 of these games back there, but there's 4 of us. Will 4 of us fit into 2 of these? No, because they have safety regulations, and even though 4 of us could pile into one of them, still, this is math class, we have perfect scenarios. 4 of us cannot sit in 2 seats. So now what do? Well, we're going to use the ones that are upstairs in storage. We are going to put a decimal point here and add a 0. And the reason is, you can do this to a whole number, and that 0 is an insignificant digit. It doesn't do anything to this. All right? This is like saying, I have $2. I have $2 in my pocket. All right? Well, what if I put a decimal here and some zeros? It's the same thing, right? That's $2. Okay? So now I have 20. And the question here, the division problem now is, I'm going to divide 4 into 20. How many 4s are in 20? Once again, do yourself a favor and learn your multiplication tables at least up to 5, and you'll know that 4 times 5 is equal to 20, all right? But when you put a decimal point here, it goes up in your answer right directly above it. It's actually 0.5, all right? I have another one up here, and it is 5 into 4. This came from the fraction. This came from the fraction 4 over 5, because you've been doing the worksheets, I'm sure, and you know that here we are talking about a proper fraction. We're working with proper fractions when we're converting to decimals and percents, not improper fractions. Improper fractions are what? That's correct, more than 1. We don't want that. Using proper fractions. 4 divided by 5. Here's 4 divided by 5. Will 5 of us sit in 4 seats? No. So we cannot divide 5 into 4. But we can make 4 look a little different by getting a little mathematical here and put a decimal point in and add a 0. There we go. Now we're doing 5 into 40. Well, you look on your chart or you get your calculator out and you will find that 8 times 5 is 40. And if you want to complete the problem, that's the way it goes. But what did we forget? That can't be a whole number. There's not 8 5s in 4. There's 8 5s in 40, we have to put a decimal point right here. Okay? That's not difficult. 4 into 3. Let me put that one here. We have 4 into 3. So what this is, 4 into 3 is the same as saying 3 divided by 4. This is 3 divided by 4. Okay? Now, everybody knows 4 does not go into 3. There's 4 of us, there's 3 seated, we can't do it, but we can change 3 so that in math class, it's possible. All right, so I'm going to put this up because this is good form. When you're doing long division problems like this, it's good form. When you put that decimal point there, go right up here and put the decimal point, because you don't want to be distracted by your baby brother and you forget to put it up there and you get the wrong answer. All right, now I have 4 into 30. Is there more than one 4 in 30? Definitely. There's a lot of 4s in 30, right? So once again, you have to kind of know your, or just, you can count it out. You can count by 4s. That's 4, then 8, then 12, then 16. Now I get kind of lost after that. But again, you can use a calculator and divide 30 by 4. And what you come up with is 7. There's at least 7, because 7 times 4 is 28. 28's less than 30. Yes, we can put this here and subtract it. There we go. Now we subtract 28 from 30. Ronnie Millsap can see that's 2. What are we going to do? 4 does not go into 2. We already did that with the last problem. But we can add another 0. Are you remembering this? Everybody's been taught this. We can add another 0 and bring that 0 down here. This is what they call, you think every time you hear the word mathematics, sometimes it's math magic, all right? And that's what this is. You put a 0 there, it does not change this at all, and you can bring that down here. Now it's possible to divide 40 into 20. We already figured out that's 5. And so 3 over 4, the decimal for that is 0.75. And you found that by division. Okay, and one more here that I have written in preparation. Every one of these I had a purpose with. That's why I'm reading them right off my sheet. And that's 5 into 3. This is a good one because this is not a real common fraction. But here we are again, 5 of us, 3 seats in the fun house. It's just not going to work. Those arcade games are only fit for 1 person in the seat. We can't do that, but we can certainly do this. There we go. We can add a 3. That's still 3. It's just a different form, and that allows us to divide 30 by 5 and get 6. 6 times 5 is 30, and so 3 divided by 5 is 3 divided by 5, and that decimal equivalent is 0.6 or 0.60. Okay? That's the first thing that I wanted to show you. All right, I would like to, for the rest of this, I'd like you to just pause just for a minute, and if you do not have your sheet with you, that conversion sheet with all of the fractions in the first column, all of the decimals in the second column, and all of the percentages in the third column. If you don't have that, then I will show you mine. And here it is. Here, this is the sheet that I'm talking about. And this is, you can see this in a lot of different forms. But what they didn't do, and this is the best one she could find, but she still spotted this is not perfect. And Mrs. D pointed out that across the bottom here, we should be showing you something. And that is, what are we working toward? And this is it. We have, let me take an example we just did. We just did 3/4 for the fraction. We came up with 0.75 for the decimal. And this, of course, translates, many of you know, we just take that number over here and we get rid of that decimal and we put the percent sign. There we go. There's our equivalent fractions and decimal and percentages for this quantity, 3 out of 4 and so on. All right, so what are we working toward? You can see on that sheet that it starts small and it ends big. Our problem with this sheet is it doesn't finish. It does not complete. What is the ultimate fraction that we can have down here? What are we signifying? When we say 3/4, we're talking about something, and let's go to pizza right away. We're talking about a 4-piece pizza, and we only have 3 slices. That's what we're talking about. We don't even have a whole pizza. So what's the whole thing? Whatever we're working with, how are we going to show that down here at the end to show we're at the bottom of the table? All right? I mean, that's not the whole table. There's one more row, and that is any number over itself. The same numerator and the same denominator. On that chart, it works out to this. This is the number 1. That's one pizza, no matter how it's sliced. This is one whole pizza. Another pizza, another pizza. We're talking about whole pizzas. W-H-O-L-E. Whole, the whole pizza. If I bring you over pizza and it looks like that, you know what I did. Yep, I ate that one on the way over. And you're only getting 3/4 of it. So for fraction, it's working its way to a number in which the numerator and the denominator are exactly the same way. And how can I prove that equals 1? Very simple. We just did division, and we just said the denominator goes into the numerator, and Ronnie Millsap can see that's 1. So that's the fraction line. Here is the decimal line. How are we going to work with this? What's down here? What's the ultimate 1 or less? What are we talking about, one thing down here? All right? Well, when I see a decimal, here's what I think. I think of one thing when I see a decimal, and that is that. All right? So what are we talking about here? If you look at this and think money, what are you thinking of? What you should be thinking of is this. Oh, that's 75 cents. Yeah, that's 75 cents. That's not even $1, is it? So if we're talking about less than 1, the last thing down here on the bottom must be $1. And everybody knows that's $1. I'm not going to put the money sign there, the dollar sign there, because we're just talking numbers here. Well, I guess I could. I put the pizza over here, which is the same thing. Now, I made the point on, I think in my last video, that when you're looking at this, you're thinking that's definitely less than 1. That's a proper fraction, and you're correct. When you look at this, that's a decimal, less than 1. That's definitely less than 1, and you're correct. Look at this, 75. Compared to these, that number's huge, right? Wrong. That number is not huge, 75% of something, because if this is the whole pizza, this is the whole dollar, what percentage means the whole thing? Like, if you ask me, Mr. Newman, how hard should I work on this assignment? And I say, give me what percent? How much percent? 100%. So when you look at this, and you look at this, that's less than what we're working towards. That's less than 1. 75% is less than 1. I don't want you to give me 75%. Would you like to coach somebody in a sport and they're giving you a 50% effort when they show up for practice? No, ask Coach Gio about that, all right? You want 100%. So these down here on the bottom are the items. This is what we are working towards. This is what we're less than. And all these fractions, all these decimal equivalents, all these percentage equivalents, they're all less than a number divided by itself, $1, and 100%. Okay? Please add these 3 to the bottom of that sheet, because that is the ultimate, that's as high as you're going to go. Because all of these principles, not all of these principles work if that is an improper fraction, or that's 1.75, or that's 110%. That's why when somebody says, I'm going to get in and I'm going to give 110%. No, you're not. You can't give 110%. You only give 100. 100's all of it. All your effort is 100%. You can't give 110%. That's just an expression that really makes no math sense. So let's move on here. I spoke before about a useful skill. There is a very useful skill, and my grandsons all learned it, and I'm hoping you can too. They learned it with number games on YouTube and children's channels, but that's what I would like you to know, that if you can count by twos and threes and fours, not so much fours, but just make it, and up to fives. If you can count by these, you're going to be able to multiply a lot easier. And math, for those of you that are in maybe 7th grade, 8th grade, 9th grade, listening to this, you have a few more years of math at Pepin, don't you? They're going to be easier years if you can just learn to count by these. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. When I was in grade school, I think we made a song out of it. I don't know. 3, 6, 9, 12, 15, 18, 21. Manning, I know you're listening for me to make a mistake. Stop doing that. 4s, 4, 8, 12, 16, 20. You can learn these. And 5, everybody do 5s, right? 5, 10, 15, 20, 25, 30, 35. All right? And then also, I think most everybody can do that. I'm going to show you that's important too. I have one of these up here is all about the 10s. All right? If I talked you into this, or if I just got your interest a little bit, have somebody take you to a dollar store. They have packs of cards in which you can just test yourself. If you watch regular television and they have commercials, you should have at least a multiplication and a division card set where you can just pick it up. Forget that commercial, they're just trying to sell you something. And if you don't have a job, you don't have any money yet anyway, and go through the cards, you'll learn math, and it'll be a lot easier and a lot more fun and a lot more interesting. All right, my next one here is we are going to talk about how the division converts fractions to decimals. All right, so we just did that. Let me bring up a different one. I did 3/4. Let me do 4/5. All right. So 4/5. So in our column here we have 4/5, 4/5, and we want to convert that to the decimals over here. What do? Well, we just did that, right? What we're going to do is divide 4 by 5. Now, you might be saying, Mr. Newber, I can't remember whether to divide the 4 into the 5 or the 5 into the 4. Let me help you out with that just real quick, okay? We need to have a proper fraction. We cannot have improper fractions. So if you do this and we have too many guys going into the arcade to sit in the seats, what do you think this one means? If you don't think you understand which ones these go, well, 4 does go into 5, so we're already on our way to solving. It can't be this. This means that your numerator is larger than your denominator. That's wrong. You have to, when you are doing the division method to turn a fraction into a decimal, you must be doing this. Well, unless you already have it memorized or you can figure it out in your head. You must do this in order to perform a long division operation and come up with a 0.8. All right? That you need to understand that. If this goes in successfully and you're going to end up with a decimal in your answer, you mixed them up. It's 4. You can go top to bottom. That's if you're using a calculator, this is exactly what you put in the calculator. 4 divided by 5. Start at the top, go to the bottom. Look, just like that. That's usually the way it works. Okay? So now we have this one for our fraction. We have this one for our decimal.